This is Professor Belden. This is trigonometry. This is Chapter 2, Section F, Part 3 of 3. We're doing the cosecant and secant frames this time. Okay, so what you notice about the cosecant, secant frames are exactly the same formulas as the sine and cosine frames. Okay, because they're reciprocals, of course. So, what we notice is that the cosecant frame is the reciprocal of 1 over sine. So the problem comes in if you look at the sine values around the unit circle. Whenever you have the sine, right, you can't reciprocate sine at the whole values of pi. So when I'm at 0, pi and 2 pi, I have a problem. So that means that every iteration of pi, I have an asymptote, which are represented here by our dotted lines. Every pi, 0, pi, and 2 pi have an asymptote. Okay. Other than that, the values go up like this and down like this. Okay. And you can notice that they follow the sine graph if you were to put one in there, because sine is the reciprocal of cosecant. Likewise with secant. Secant is reciprocal of cosine, so the secant reciprocal is 1 over cosine. And if you go around the unit circle, the problem now is at every half pi, I can't reciprocate it, right? Because 0 is 0 over 1. If I try to reciprocate it, I get 1 over 0. So that might be the cosine, but that is the secant, which isn't going to work. That's undefined. Hence why every half pi, I now have asymptotes here. Okay, and again, this graph looks like this. Keeps repeating itself, obviously. They go off like this. And you notice if you graph the cosine on here, they follow the secant graph. Okay, so that's the basic frames of secant, cosecant. Alright, let's do a couple examples. So the first one is the cosecant graph, which means that every iteration of pi, I have an asymptote, because I can't reciprocate 0. Alright, I'll have a point here and here, and it's going to go up like this and down like that, obviously. But you don't need to put that in there. It's just for references for when you make the actual graph. We'll just keep those points there in the meantime. Okay, so first we need to figure out the phase shift, because these are just like sine and cosine. So we need to do our values here. So A, oops, erase that actually. You guys need to put a plus 0 on the end, because there isn't one for D. Because A is 5 halves, B is 2, C is negative pi over 2, and D is 0. Okay, so phase shift. Phase shift. That is x equals c over b. C is negative pi over 2, and b is 2. So I'll multiply it by 1/2 and 1/2. That gives me negative pi over 4. That is going to be our starting value. So negative pi over 4. Okay, so this is back to sine cosine. So our period is 2 pi over b, or in this case 2 pi over 2, which will give me pi. So that is our period. So the distance from here to here is pi, right? So this over here must be pi plus the negative pi over 4 for the total distance, right? Because this distance is pi. So if I go from negative pi over 4, a pi distance over, that's going to leave me at 3 pi over 4 for a total distance of pi. Okay, so we can erase the math here. We can erase this line that represents the distance of 1 pi. Okay, so we have a total distance of 1 pi from negative pi over 4 to 3 pi over 4. So now we want to figure out the ones in between. So that's negative pi over 4 plus 3 pi over 4, all divided by 2. So if we do that, that's going to give us 2 pi over 4 divided by 2, which is going to basically be times it by 1/2 and 1/2. Cancel, 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 cancel. That's a pi over 4. Okay. Alright, halfway between negative pi over 4 and pi over 4 is 0. You can add them up if you want to. You get 0. Divide by 2, you still get 0. And the next one is 3 pi over 4 and 1 pi over 4 gives you 4 pi over 4. When I add these two up, divide that by 2. Well, that's just pi over 2. And there is our x-axis frames. Okay, let's erase the extra junk here. Okay, let's do our y-axis. So our y-axis is d plus a and d minus a. Okay, d in this case is 0, so that makes no difference. And the a value is 5/2. So we get 5/2 and 5/2. That makes a very simple one here. Of 5/2 and negative 5/2. So if I add them up and divide by 2, I get nothing. Okay, so now we can do our domain and range. So for simplicity's sake, so it goes forever up and forever down, right? But there's a gap in between. It's between negative 5/2 and 5/2. There is no value. So going from least to greatest, it goes from negative infinity to negative 5/2. You can't get to infinity, but you can get to 5/2. Union 5/2 to infinity. Okay? In the domain, it can go forever left and forever right, so that's x is all real. But every fourth I can't, so fourth, negative 1/4, 3/4, I'm not any good. But those are all odd values of fourths, right? 1, 3, 5, so it's all the odd values of it. So except x cannot equal n pi over 4, where n is an odd integer. Okay, so basically you can't have those fourths. Whether it's, obviously 2/4 is a half. Those are fine. It's just the odd fourths: 1/4, 3/4, 5/4. Okay, so let's use this to make our actual graph now. So if we look at our denominators here, we have fourths and halves. So since fourth is the biggest denominator, we're going to use fourths for our graph. Okay. I'm not going to label the whole thing this time because we just don't need to. Okay, so if I go by fourths, I got 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and 8/4, of course, going the negative because we need a little bit of negative here. Negative 1/4, negative 2/4, negative 3/4, negative 4/4, negative 5/4, negative 6/4, and negative 7/4. Oh, a little mess up there. Alright, so that's a negative 7/4. I don't know why it keeps doing that. We'll just leave it. And of course, negative 8/4 is 2 pi. Okay, so our asymptotes for every fourth. So we have asymptote at the fourth, and you can add one more in there if you want to at the 3/4. You can keep adding them if you want. What's important is we had from our frame is at 5/2, we had a positive one up there, and at negative 5/2, we had another negative one. So our graph went up on this side and down on this side, and it'll repeat ourselves. If you wanted to make more cycles, you could, because the next one obviously would be up here, the next one would be down here, and you could would have to add in more asymptotes too. But you only really need the first cycle, and this is the first cycle here, basically. The other is just ancillary extra because it repeats itself as you go around the unit circle multiple times. All right, so pause the video, try the student problem. Okay, next one, secant. The problem is with secant is every half pi we have asymptotes because you can't divide by 0. So go to the half pi on the unit circle. You notice that the cosine values are 0. You can't reciprocate those. Okay, so typically the secant would have its points right here. Okay, and it would go down like this and up like this. Right, that would be our typical secant graph. However, here, a little bit of a problem. It's not that way. Because we have a negative, it flips it. Therefore, if it's flipped, they go the other way. Positive becomes negative, negative becomes positive. Okay, let's do our values here. So A is -2, B is 3, C is 0, and D is 1, because you notice there is no C value in there this time. Okay, just use this 0 as a placeholder. Okay, so phase shift, x equals C over B, but C is 0. Doesn't matter what B is, because I'm still going to get 0 is my initial value. My period is 2 pi over B, so 2 pi over 3 is where I'm going to end, because 2 pi over 3, if I go from 0, 2 pi over 3 over, I end up at 2 pi over 3. So that one's pretty easy to calculate. So at this point, we just had to add them up, divide by 2. So 0 plus 2 pi over 3 is 2 pi over 3, divided by 2 gives you pi over 3. If I add 0 and pi over 3, I just get pi over 3 divided by 2. I get pi over 6 is my final answer. And then pi over 3 plus 2 pi over 3 is 3 pi over 3, which is just basically pi. So that gives me pi over 2. Okay, so now we can do our domain and range. Well, if we know this goes forever down and forever up, if we actually made the graph, but there's a gap here between the two values. Okay, so we're going to figure out what those are. So that's D plus A and D minus A, where D in this case is 1, and A in this case is absolute value becomes a 2 when you absolute value it. So that's a 3 and a -1. Okay, so that's 3, that's -1. So if I add those up, I get 2 divided by 2 is a 1. Okay, so it means there's a gap between -1 and 3. So going least to greatest, I get -infinity to -1, close box, union 3 to infinity. Again, going least to greatest. And the domain looks like we have a problem on some 6's, but we're going to leave that out for now. It's a little complicated, but this is enough to make our graph. Noticing we have fractions that are 6, thirds, and halves. The largest denominator is 6, so we're going to go with that to make our graph. And again, we're just going to make the initial cycle. We don't need to make all of the cycles. Okay, so numbering by sixths, 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6. That's 3 pi over 2. Shoot. 10/6, 11/6, and of course 12/6. Okay, so our asymptotes were at pi over 6 and pi over 2. And the important points that we made were at -1 at the 0. It was at 3 at the pi over 3. And it was 2 pi over 3 was at -1. Because essentially our graph went like this, and like this, and like this. Okay, so that's the initial cycle. Of course, they do repeat, so it's going to go negative on this side, positive on this side, and you have more asymptotes. But we were just looking for the first cycle, so you didn't need to add on these pieces. You were just showing the first cycle. If you want to add more cycles, you could, and it will repeat itself up here, of course. And that is the end of part 3.